Question 16b. Note that this question has been modified to comply with the current syllabus. A particle moves in a straight line starting at the origin. Its velocity, v meters per second, is given by v equals e to the power of cos t minus 1, where t is in seconds. The diagram shows the graph of the velocity against time. Using 3 applications of the trapezoidal rule, estimate the position of the particle when it first comes to rest. Give your answer correct to 2 decimal places. The following are the modified marking guidelines for question 16b. For 1 mark, we have finds the time at which the particle first comes to rest, or equivalent merit. For 2 marks, we have uses t equals 0, t equals pi over 6, t equals pi over 3, and t equals pi over 2 in the trapezoidal rule, or equivalent merit. And for 3 marks, we have provides correct solution. The particle comes to rest when the velocity v equals 0. Now we need to find the smallest value of time t, where t is greater than 0, when the velocity v equals 0 by solving the equation e to the power of cos t minus 1 equals 0. Adding 1 to both sides of the equation and then taking the natural logarithm of both sides, we have cos t is equal to 0, and therefore t is equal to pi over 2 seconds. Now the distance travelled is equal to the integral from t equals 0 to t equals pi over 2 of e to the power of cos t minus 1 dt. Using the trapezoidal rule with 4 function values, starting from t equals 0 to t equals pi over 2, the values of time are 0, pi over 6, pi over 3, and pi over 2. So we need to make sure that these values of time are evenly spaced. And v of t, or the function value itself, when t equals 0, v of t is equal to this decimal here. We could have kept it in exact form, but I thought for the purpose of this explanation, I've just written out the decimal approximation. V of t, when t is equal to pi over 6, is this decimal. V of pi over 3 is this decimal here. And v of pi over 2 is equal to 0. Now by the trapezoidal rule, the distance travelled is approximately equal to pi over 12, so that's the b minus a on 2, outside of 1.718281828 plus 2 times this function value plus 2 times this function value plus this function value here, which is 0. And that equals, or is approximately equal to 1.51 meters, correct to 2 decimal places. The following is the modified feedback from the Marking Centre for question 16b. Students should quote the reference sheet for the trapezoidal rule and understand the meaning of b minus a over 2. In better responses, students were able to understand the time when the particle comes to rest occurs when v equals 0 and show substitutions into the trapezoidal rule. And areas for students to improve include understanding the difference between radians and degrees when using trigonometric functions, understanding that 4 function values are required for 3 applications of the rule, and simplifying expressions that involve a fractional common difference within a fraction.